Good morning, students. Students, we are studying the chapter Forces and Laws of Motion. Based on the previous classes, I think you have a superficial idea about the term force. Students, as you know, we can't see the force, but we can feel and experience it by the effects it produces in different bodies, like it changes the direction of any body, shape, as well as it can accelerate a body. That means it can change the state of rest of any body from rest to motion. So knowing that a force can produce such a huge amount of effects, it has applications in every field of human life. Like if we take few examples, like if you want to construct a road, the roller machine which is being used to smoothen the road requires a certain amount of force which should be applied on the road. Similarly, if you want to construct a dam on the river bank, what amount of load, force or pressure is being utilized, or what should be the materials used for the construction of dam requires the knowledge of force. Similarly, if you want to use or do farming or harvest the field or irrigate the field, we should know how much amount of force is being used to plow that particular field or smoothen the soil for proper agricultural purposes. Even if we want to print a newspaper or we want to construct a machine like aeroplane, some turbines for the thermal power plants, boilers for the thermal power plants, every area has some amount of requirement of a certain amount of knowledge of the force. So students, knowing such a huge number of applications, we should know the magnitude and the point of application of force. So to represent a force, we use an arrow. This is an arrow. Suppose we take an example of this block and a person is applying force by his hand on that particular block. So students, this is the point at which the hand is being in contact with this block. So this contact point at which the force is being applied is known as the point of application of force, and the direction towards which this force is being applied by the hand, this direction is considered as the line of application of or the action of force. So students, to represent a force, we use an arrowhead with a line with an arrowhead. So students, this line or the length of the line shows the magnitude of the force, that is 10 Newton in this case. So in this case 1 centimeter is equal to 2 Newton. So every centimeter is of 2 Newton. So the whole length of this line is 5 centimeter. So that means it is 10 Newton force. And this arrow is pointing the direction at which the force is being acting, because force is a vector quantity. So we use the magnitude as well as direction for the force. So students, in this figure you can see this is the point at which the hand is in contact with the block. So this is the point of application of force, and if we draw a straight line with this point towards in this direction, it will be the line of action of force. So the length of this line, this is the magnitude of the force which is indicated here, and this arrow pointing towards in this direction, it will be the direction of the force. So students, now we know how to represent the force. The force can be classified into contact forces and action at a distance forces. So students, what are contact forces? From the term we can understand that contact means when the two bodies are in contact. So there are various examples. I have pasted just 6 examples in front of you. So in every example you can see the person who is applying the pull or the push or any kind of a force is in contact with that particular body. So you can see this lady have bought some vegetables from the shopping market. So he is moving this trolley by applying a force on this handle. So this woman is in contact with this trolley and he is applying force in this direction. So this is a contact force. So similarly, this child is trying to pull water from the well for his household activities. He is helping his mother. So in this way, he is constantly pulling the rope with the help of this pulley, and a particular kind of a tension force is acting on this rope for pulling this bucket out. So in this way, we can understand that this child is in contact with the rope and he is applying a pull force to drive the water from the well. So this is a contact force. Similarly, this person is pushing this table in this direction. The table is in contact with the floor, so there is a certain kind of a friction force is acting between the table and the floor, and even there is a contact between this man and this table. You can see his hands are in contact with the table, and he's trying to push this table in this direction. So this is an example of contact force. Similarly, both this child is running, and this person, his friend, is chasing him. So they have a competition with who's going to win, but the person on the cycle are surely going to win because he's applying certain kind of a more force. So the bicycle is in contact with the floor, so there's a contact force between the bicycle, the weight of the bicycle, and the friction force which is acting on the floor. And even this person is applying a force on this bicycle, so the person is sitting on the bicycle is in contact with the bicycle. So in this way, the force is this kind of a force is also a contact force. And even this child is running on the floor, so he's moving the floor backwards. He's putting a certain kind of force on the floor. So the backward force, or the opposing force, is the frictional force, and the floor in reaction with the person, he is creating a reaction, a force on this child. So we can understand it by the Newton's third law that every action has a equal and opposite reaction. So this child has applied a action force, that means in the form of friction, in the backward direction to the floor, and the floor is applying a force on this child to move him forward. So in this way, all these forces are a kind of a contact forces. So we should also understand what is action at a distance force. So from the term we can understand that those forces which act through a space between the two objects, or which acts from a particular distance and they are not in contact, such a forces are known as the action at distance forces. So there are various examples. So as you know, students, from the Newton's law of gravitation, in which I explained in the first introductory video of the chapter forces and laws of motion, the Newton states in its Newton's law of gravitation that every heavenly body attracts every other heavenly body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So in this case, the sun is attracting other planets. So there is a kind of attractive force, means that is an action at a distance force between the sun and the planets, and between the planets. So such a force will be named as an action at a distance force. Yeah, and even students, the magnetic poles are attracting the iron bearings, because iron bearings are a certain magnetic material, and because of the charges and the magnetic field of the magnet, the iron bearings are attracted towards the magnets, towards the north and the south pole, because of the magnetic field of the magnet. Similarly, when we comb our hair, the comb becomes charged. So when the comb becomes charged, it can attract the charged other particles like wrappers of the paper or the straw can be attracted by the comb, because they have opposite charges, and this is the example of an static electricity. And even students, you are knowing about the gravity, when the earth attracts any object towards itself is known as gravity. So this apple is falling from the tree downwards. So this is an example of gravity which attracts everything downwards. So this apple is falling downwards. That means because of the attractive force of the earth, the apple is falling downwards. So this is an example of an action at a distance force. So these are the examples of two types of forces, that is contact forces and students action at a distance forces. So I think you have a basic idea about both these forces, and I want you more examples to express yourself in the what are the different kinds of contact and action at distance forces. So please write some more examples based on it, and please understand properly how to represent a force which is represented by a line pointing in a particular direction. The length of the line represents the magnitude of the particular force, and the direction in which the arrow is pointing will be the direction of the particular force. So thank you students very much, and in next video we are going to discuss about the balanced and unbalanced forces. Okay students, thank you very much.